Hey, good morning or good afternoon, everybody. This is Mr. Kinney. We're here with period 2. Period 2, say hi to everybody. Hello. Oh, yeah, cool. Yeah, they're still half asleep. Okay, so that's okay. Well, we're going to go over this. We're going to go over the odd review questions on here. So the first one, let me zoom out so we can see this. Find the second element's name and symbol. Oh, yeah, that was wasn't worded very well. So let's see. I would like you to find the name of the element, the second element in period 4 of the periodic table. So make sure you all have your periodic tables handy. And let's see. Period 4. Is this period 4 right here where I'm pointing out? Now it's group 4. Periods go this way. So what is the name of the second element in period 4? Calcium. So calcium or Ca. I'm just going to put the symbol there, but it's calcium. And let's see, period 5. Okay, is this period 5 over here? No. Okay, periods go across. There's 7 periods in our bell schedule, and there's 7 periods on the periodic table. What is the name or the symbol of the second element in period 5? Sr or strontium. Sr. All right, second element in group 13. Okay, there's no 13 on the side, so it must be over here. And remember, the word group has up in it. It reminds you they go up and down. So what is the second element in group 13? It's aluminum. I'll just Al. And then group 17. Second element? Chlorine. So that was just mostly to get you to realize that groups go up and down. Okay, so this is group 1, 2, and 3, and then these are periods 1, 2, and 3. They go that direction. Groups go up and down. All right, let's see. Any questions on that one? All right, let's do number 3 here. How many shells and valence electrons do the following have? So shells, what tells you number of shells on the periodic table? Groups or periods? Which one? It's going to be period. So whatever period it's in, that tells you how many shells. So lithium is in which period? Okay, it's in period 2. So lithium has 2 shells. Okay, I'll draw its 2 shells there. And how many valence electrons does lithium have? And that's what group it's in. What group? 1. Group 1. So I'll just put 1, kind of do a modified, like a Bohr model here. All right, calcium. How many shells does calcium have? It's right here on the periodic table. 4. Okay, it's got 4 shells. So 1, 2, 3, 4. And how many valence electrons does calcium have? 2. It's got 2. It's in group 2. So 1, 2. All right, argon lives over here on the periodic table. How many shells does it have? 3. It's in period 3. So it's going to have 1, 2, 3 shells. And how many valence electrons do most of the noble gases have? How many valence electrons? Most of them have 8. Helium only has 2. That's an exception. I probably won't throw that at you on a test. So 8 valence. I'm just going to put 8 because it's easy to write. There's 8 valence electrons. And helium doesn't follow that because it only needs 2. Its first energy level is full. Okay, tellurium. Uh-oh, help me out. Where's Te, everybody? Is it over here? Oh, there it is. Okay, it's right there. How many shells does tellurium have? 5. Yeah, I think 5. 1, 2, 3, 4, 5. It's in the 5th. So it's got 1, 2, 3, 4, 5 shells. Wow. How many valence electrons does it have? It's in group 16. Okay, 6 valence electrons. And the valence electrons are the outer electrons. Lastly, chlorine. How many shells?
3.
It's in period 3. 1, 2, 3. How many valence electrons? 7 valence electrons. Okay, so there we go. All right, I added number 5 because I left it off. So, if a metal gains 2 electrons, what's the charge on an electron? It's negative. So electrons have a negative charge. All these atoms, before they gain or lose electrons, they're all neutral. So metals are neutral until, NEUT, all atoms are neutral until they either give or take electrons. So if a metal, which starts off neutral, gains 2 electrons, what will its charge be? It's neutral, and now we're going to add -2. What does 0 plus -2 equal? Negative 2. It'll become a negative 2 ion. And it turns out all the elements in group 16, they have 6 valence electrons. They only need 2 more electrons. So it turns out all the elements in group 16, they tend to form negative 2 ions. So that could be like oxygen -2 or sulfur -2. But the main thing is you got to make sure you can do on the test is if it's a negative ion, it's gained electrons. If it's a positive ion, like let's say lithium metal, it had to lose negative charges. Okay, so, oh, wait a minute. If a metal gains 2 electrons, then that's kind of stupid because my question's totally wrong. It should be a non-metal. Non-metal. We're gonna change that right now. Non-metal. Oops. Because non-metals don't gain electrons. So I need to make that. Yeah, and that's why my examples were O2 there. Whoa, sorry, my bad there. Only metals throw away electrons, non-metals gain. All right, well, I'm embarrassed now, but I'll get over it. 7, which metal is most reactive? So let's see, I'm just going to do this chart over here. There's the zigzag line. Which metal is most reactive, ladies and gentlemen? It's going to be the one FR. So the closer to the bottom, most reactive metal is down there. So the closer you are to francium, the more reactive you are if you're a metal. Was that the last one? Oh, which is the most reactive non-metal? Now, noble gases do not react, so I'm going to take those out. Fluorine. It's going to be fluorine. That's the most active non-metal. And that's on your trends. So if you need to draw this chart like that, do it on your summary page. All right, we did that. Most reactive metal we said was francium, or the one that's closest to bottom left. Bottom left. And most reactive metal is fluorine, or the element that's closest to the top right, not counting noble gases. No noble gases. They don't react. All right, number 9. What are the trends for atomic size as you go across a period? So what do? If you go across the period, what do the atoms do? They get smaller. So you can kind of, oh, maybe I should make that. So if you need to, as you go this way, because the nucleus gets stronger, the atoms get smaller. What's the trend as you go left to right? Smaller. Let's see, number 11. What are the trends for electronegativity as you go across or down the periodic table? Oh, I need to look at the trend for it, because that's one, I'll let you know, we'll give you a chart. We're not going to make you memorize that. So what did you all get? What are the trends as you go across the periodic table? Oh, I'm just going to, I'll just draw one here because it's just easier. Electronegativity. Where's its largest?
Right and top. Top right.
Top right. Now, the noble gases do not have electronegativity. They're 0. So it's going to be that guy right there. Which one's that?
Fluorine.
Element fluorine. So as you go this direction, I'm going to draw one of those arrows that gets bigger as we go that way. Electronegativity increases because the nonmetals really need them. And I guess the trend as you go up, the higher you get, the bigger the trend is. Electronegativity. And you've got this chart, and like I said, this chart will be provided for you. You just need to be able to read it. You don't have to have that particular trend memorized necessarily. Which element has the largest value? We said it was fluorine. Okay, number 13. Which bond type shares pairs of electrons? Okay, so which of these is sharing electrons? So it's going to be covalent. They share. So we've got this chart that I've been throwing at you constantly, so to speak. Uh-oh, now I lost it. So this chart doesn't help you when we're talking about whether they share, give or take, and naturally I lost the chart. This little chart, the one that looked like this. So this one tells you if it's nonmetals to nonmetals, but you're also going to have to make sure you know. Was I off the page there? Why didn't you tell me? Please, you gotta help me. So I did this recording and I'm totally off the page there. I mean, hello, wake up out there. I need your help here, okay? Well, you're not the only person in the class.
We're all taking it.
So, number 15, which of the following represents an ionic compound? So ionic compounds, that's going to be metals to nonmetals. So which of these have metals and a nonmetal? Is phosphorus a metal or a nonmetal? Get out your periodic tables, look. Nonmetal, how about chlorine? Okay, so this compound would then be probably covalent. We're looking for ionic, so I'll cross that off. We've got nitrogen. Is it a metal or a nonmetal? And how about oxygen? Okay, that's covalent, so no, that's not ionic. Barium, metal or nonmetal?
That's a metal.
That's a metal. And then oxygen?
Non-metal.
Non-metal. Okay, so that's going to be ionic. Cool. And then carbon, metal or non-metal?
Non-metal.
Sulfur?
Non-metal.
Okay, that's going to be covalent. So the metal bonded to the non-metal. And this would be also, the other definition is they give or take electrons. Give or take electrons. Okay. You make sure I stay centered up there, okay? I need you to center me. Ionic compounds are made from bonding what to what? Metal to non-metal. Metallic compounds are made from bonding what with what?
Metal to metal.
Metal to metal. All right. On this side, number 21, wanted you to balance this reaction. So, recommend you use the T-chart if it helps you. If the T-chart isn't needed, don't do it. But we've got aluminum and oxygen, aluminum and oxygen. Let's see, which element should you balance last? We should do aluminum last, because that's, you need pure metal by itself, do it last. So it looks like then oxygens we need to balance. We've got 1 aluminum and 2 oxygens on this side. We've got 2 aluminums there. We've got 3 oxygens here. Does that look, did I do that right so far? Let me redo this. So there's, no, 2 of those. Okay, so what's the smallest number that both
6.
2 and 3 goes into? So 2 times what is 6?
3.
And so what's 3 times 2?
6.
So I'm going to cross that off. So now it's 6. So now we got to come over here, and we've got 3 oxygens. 3 times what equals 6? 2. So now how many aluminums do we now have?
4.
We got 4 aluminums now. How many oxygens do we now have? Going to be 6 of them. The oxygens balance. Now what's nice is we need a total of 4 aluminums over here. What coefficient do we need to put at 4? So on the test, you'd look, if this was one of your equations, you'd look for the one that says the coefficients are 4, 3, and 2. All right, let's see. So which one do you balance last? Aluminum, because it's a metal. Did that, okay. Number 23, label the reactants and products. Okay, what are these? Reactants or products?
Reactants.
What do you say, Group 7? Reactants or products? Reactants. And let's see, Group 1, what are these over here on the right side of the equation? They're the products. They are what are produced. Okay, what are the, okay, did that. Oh, what does that arrow mean? Group 2, what does that arrow mean? What does the arrow mean? What? Yeah, it's going, well, it's actually going to the right. It's not going to the left until you get to equilibrium. You don't know what the arrow means? Does it mean equal? That the atoms on this side have to equal the atoms on this side?
Oh, yeah.
Atoms equal atoms. And then somebody else said, what kind of change has occurred? A chemical change, or a change anyway. Change, there we go, chemical change. Oh, it's not centered anymore? So this is like an equal sign, and it's telling us the reaction is going this direction. There's a chemical change. All right, did we get everything on 23? Label the reactants. What? Okay, did that. 25. In the reactants, how many total atoms of oxygen? Okay, let me erase some of this. So how many oxygens do we have? We've got 2 molecules of this, and every molecule has 3 oxygens.
6.
Okay. How many irons do we have? Oh, wait, sorry, I was on the wrong side. I said reactants.
We still have 6.
We still have 6. Okay, yeah, it's a balanced equation. How many irons do we have over here in the reactants? There's 4 of them. So let's see. Number 27, label the names of the 3 and the little 2 on the oxygen gas molecules.
3 is coefficient because that's
This is the coefficient, and it tells you number of molecules. That one's been throwing a lot of students. And the little 2 must be the subscript, and it tells you number of atoms in the molecule. All right, let's see. Number 29, explain the law of conservation of matter. So, can you create or destroy matter? Okay. Can't make or destroy matter. And that was the reading passage we started with the Lavoisier's, about him doing all of his tests in sealed containers. You can always account for it. Number 31, endothermic. The N gives it away. Does that feel nice and cool, or does it feel extremely hot?
nice and cool.
It'll feel nice and cool. Or if you have the reaction, maybe you have compound A plus compound B plus heat energy,
Oh,
changes into compound AB. So if you have heat part of the reactants, that means it's endothermic, it's taking heat away. And if you do this reaction in a test tube, it'll feel cold because it's taking heat away. Oh, yeah, we're going to add 2 questions. Let's see, where's my, I lost the paper now. Sorry, everybody. Here we go. Question 32
but we're just doing odds.
and 33. Smart guy. All right. So what I'd like you to do, well, okay, we got to do 32. I'm going to do 32 now because 33 won't make sense. Draw the pH scale. Draw the pH scale. What does it go from? Oh, you're going like, what? Okay, go to page 17, please, in your notebooks. You should have our endothermic, exothermic lab. And did I have you tape these down yet? Because there was a backside. If you didn't tape these down, get them taped in there. There's the pH scale. What does it go from?
0 to 12.
0, 7. It does not go to 12. Next answer, you 14.
Oh, that was 11.
1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. You should have come to school on Monday. Okay, so there's the pH scale. Which is the acid side? Left side? Or this side over here, this is acid?
Yeah.
So if you had a pH of 1, it's an acid. How about a pH of 14?
Base.
Base. And then what's 7 going to be?
Neutral.
It'll be neutral. All right, we're going to end this one here. Thank you for your help over there. I would have appreciated if you would have kept me centered. I need all the help I can get.